Welcome to NGR 7848, Week 1, Introduction to Biostatistics. This presentation is really a brief overview of what we are going to learn in Week 1. So first, I just want to talk a little bit about what is biostatistics in a very brief way. And I want to have some discussions on study designs, and then quantification of disease risks. These are actually the main topics of chapters 1, 2, and 3. So what is biostatistics? So biostatistics is the application of statistical principles in medicine, public health, nursing, or biology. And this quote is from the author of our textbook, Lisa Sullivan. Basically, biostatistics is kind of a branch or an application of statistics. And statistics is the art and science of making decisions in the face of uncertainty, and statistics is based on data. Okay. So what is statistics? So statistics is the science of learning from data through design, measurement, analysis, and reporting. And statistics is a mathematical science pertaining to collection, analysis, interpretation, and presentation of data. Statistics is very widely applied in many different scientific disciplines, such as business and government, medicine, and industry. And statistics is really for quantify uncertainty using probability theory. Okay. Principles of statistics are applied to learn the truth in the noisy data full of uncertainty. So uncertainty is we have unpredictable outcomes of certain random processes, and we really want to quantify the probability of some event to occur. Okay, so probability is the foundation of statistics, and statistics by itself is a branch of science for describing or handling uncertainty. And statistics is a part of the scientific methods, which really emphasizes on study design. Usually study design is the first step of scientific research. And choosing a good study design is critical for answering the scientific research question. Okay, so if you have had an exposure to scientific methods, you know we start with the research questions and develop hypotheses, and then we do study design to design our study to collect data. Okay, so that's what study design is about. Very roughly speaking, you can classify study design into experimental studies and observational studies. Okay, in observational studies, basically there's no intervention. We basically observe what happened and record, and then we analyze data and try to answer different research questions. So in observational study, you have cohort studies, you have case control studies, you have cross-sectional studies, and you have ecological studies. Okay, I'm not going to go into details of each of these type of study design. You should be able to find information in the textbook. Please make sure you finish the reading assignment to learn about each different type of study design. And we also have experimental studies in which we have intervention and we actually carry out experiments. Very kind of rigorous study designs, randomized control trials, RCTs, used a lot to evaluate the effectiveness of interventions, such as a new drug or a medical device or a nursing intervention. And also there's a non-randomized control trials. Basically you have an intervention group and you have a control group, but you just cannot randomize the intervention. For example, if you want to study the potential harm of a cigarette, you just cannot, it's not ethical to randomize people to smoking group. Okay. Another very important issue is measurement. The measurement is really, we want to decide, how do we, what do we measure and how are we going to measure it? Okay, and this is really critical for quantitative research. And associated with measurement theory, the two most important indices for a measurement instrument is the so-called reliability and validity. Basically, these two properties of the measurement tool you use will determine the quality of our scientific data. Okay, measurement is not really well taught, well described in any PhD curriculum in scientific research or statistics. Okay, so they're mostly from psychometrics or educational measurement, but we will not be able to actually go into details of measurement, but later I will show you the importance of measurement in determining statistical data analysis. Quantify disease risk. So we're really getting to quantitative research. So the first thing we want to do is try to quantify the disease risk. For example, we got prevalence and incidence in a single population, or ratios for comparing disease risk in different population, or what we call relative risks. Okay. And of course, you have a lot more quantitative disease risk measures, such as absolute count, ratio, proportion, percentage, rate, risk odds, or odds ratio, those kind of measures. And please make sure you read Chapter 3 carefully to learn more about these disease risk measurements. And make sure you know the difference between prevalence and incidence. So process of quantitative research, probably have seen this. It's a process. We start out with research questions and we develop theory or hypothesis, and then we do study design when we choose measurement tools, and then we do the study and collect the data, and then we analyze the data, and then we interpret the data analysis result, and then we answer the research question. Our class here is really focused on data analysis. So it is just one part of the process of quantitative research. But you should keep this in mind. It's not a single activity. It's really one part of the process of quantitative research. And one important point I want to make is really the impact of study design on data analysis. Basically, the study design may dictate which statistical method should be used. For example, if we have a pre-test and a post-test design, leads to a paired sample. For example, you just start measure a person before and after they take a blood pressure lowering drug. You measure their blood pressure before and after they take the drug. Then that's a pre and a post design. And this will actually create a paired sample. So if we want to compare the blood pressure before and after, then we have to use the so-called paired t-test. But if we have a randomized control trial, and the two groups will be independent of each other and they're not paired, so we use the independent sample t-test. Another important factor is the measurement. Okay, measurement leads to type of data, which determines which statistical method should be used to analyze the data. I'm not sure if you have seen this. There are different levels of measurements, nominal, ordinal, interval, ratio. They reflect how much detail we want to the measurement to have, okay, and how refined we want our measurement to be. Okay, and I have posted a video specifically on the levels of measurements. And levels of measurements leads to different types of data. Different types of data require different types of statistical data analysis method. For example, if we have proportions, chi-square test should be used to compare two proportions. And if we have continuous variable and we want to test if it has equal means in several groups, then we could use ANOVA, the analysis of variance technique. Okay, so study design and levels of measurements are two critical factors for us to determine which statistical method to use. And that's all for this presentation. Thank you for listening.